Our project is entitled Thermal Resistance of a Camping Pad by Garrett Lamb and Andrew Horton. The objective of our project is to calculate the thermal resistance of a specific camping pad and compare it to the manufacturer's claimed R value. There is no set standard for determining R values amongst camping pad manufacturers, so the R values for essentially the same pad manufactured by different companies can yield different R values. This is due to the fact that some manufacturers actually run a test to determine R values while others run vague approximations. Our experiment includes a liter of water in a plastic bag at an initial temperature of 74.7 degrees Celsius. The bag was placed directly on top of our closed cell polyolefin pad. On top of the bag were 4 layers of 9/32 inch felt to create an insulated environment. As the goal of the project was to determine the R value of the pad, we wanted to have as much heat as possible exit the bag through the pad as opposed to through other directions. While doing the experiment, we believed that more heat would be lost through the thin felt than through the thicker foam pad. We also assumed that there was no free convection on the outside due to the insulation provided by the felt. While conducting this experiment, some assumptions were made. We are approximating the water in the bag as a flat plate, and as such we won't be losing any heat through the sides of the bag, but entirely through the top and the bottom. The felt was taped to the pad to prevent any heat from leaving through the edges. The felt was also wrapped as tightly as possible over the plastic bag to limit the volume inside of the pad and felt enclosure. We assumed that the ambient air temperature was equal to the temperature of the surface of both the pad and the felt, especially once the temperature reached steady state values. We expected it to take about 30 minutes for our water to reach steady state and recorded the change in temperature every 2 minutes. This was not the case. After 30,960 seconds, or nearly 8.5 hours of cooling, we were near steady state but hadn't quite reached it. Our ambient air temperature was 19.7 degrees Celsius, while our water temperature after this amount of time was 25.8 degrees Celsius and was changing about 0.1 degrees Celsius every 3 recordings. Due to the near flatline slope of our curve, we assumed this could be approximated at steady state. A lumped capacitance model was assumed due to a low temperature gradient. A convection coefficient was calculated from this model. Using the general lumped capacitance equation, Q total was calculated. This total Q will be leaving the water and exiting either up through the felt layers or down through the pad. The sum of heat losses through the felt and the pad yield Q total. Q conduction equals Ka T1 minus T2 all divided by L for both the pad and the felt. These are used to calculate the K value for the layer of most interest, the pad. This K value is used to calculate the R value for the pad. A convection coefficient of approximately 11.9 watts per meter squared Kelvin was calculated. Total heat out of the bag was 22.89 watts. Of this, 18.78 watts left through the pad, while the remaining 4.12 watts left through the felt. Using these values and a K value obtained from the book for felt, a K value of 0.31 for the pad was calculated. Using this K value, the thermal resistance for the pad was calculated, giving a value of 1.63. The manufacturer of our foam pad claims an R value of 1.4 for for a 3/8 inch thick pad, while our pad is 1/2 inch. And we have a calculated R value of 1.63. If our camping pad were 3/8 of an inch, this would yield an R value of approximately 1.22 due to the linear relationship between pad thickness and R value. This yields an R value difference of about 0.18, or a percent error of approximately 13% for equivalent thicknesses. While this may seem like a large percent difference, it really isn't, due to the R value of pad not being the only factor in pad selection. Our hypothesis of losing most of our heat through the felt was inaccurate. While the felt acted as a better insulator than the pad, it wouldn't be practical to use as a camping pad. Felt doesn't offer padding from the ground. The felt also isn't waterproof, while the pad is, so it wouldn't work well in damp or a wet environment, such as a mossy spring floor or for winter camping. After all is considered, an R value of 1.4 versus an R value of 1.22 for a 13% difference won't likely influence picking one pad over the other.